We're going to talk about dividing complex numbers today. And when we talk about division, we're actually going to use the fractional form of that. A fraction is a form of division. We have a plus bi divided by c plus di. Now we're dividing complex numbers, and when we talk about this division, we're not going to talk about it in the traditional sense where you're going to use, a division bar and do a whole bunch of calculations that way. We're going to make it simpler by rationalizing the denominator, kind of like we did when we were talking about square roots in the denominator and irrational numbers in the denominator. We are going to make it a rational number. Right now, it is not a rational number. That d, as long as that d is something other than 0, we know that this is going to have an imaginary part and not be rational. And so we're going to rationalize that denominator by manipulating the equation. Now, I know in real life, you're not supposed to be going around manipulating people, but in algebra it's highly encouraged to manipulate. In fact, even your grade may depend on it. So we are going to do some manipulation here. Now, a lot of students like to just do that division straight through those addition signs, which you cannot do. You cannot do it with natural numbers. You cannot do it with complex numbers. Anytime you have a plus or a minus inside that denominator, you cannot just do division down like this. That's not the same as a divided by c plus b divided by di. So same thing with natural numbers, you can't do that. If you were going to do this calculation, you would do 10 plus 5, which is 15, 2 plus 1, which is 3, and you would get an answer of 5. Now, if you tried to do the big no-no, you would get a totally different answer. Don't ever do this. So if we did 10 divided by 2, that would give us a 5. 5 divided by 1, add them together, we get 10, which is twice as much, and then our whole number system and calculations are going to fall apart. So you may not just divide through there. We're going to look at how you can manipulate that denominator in order to get a rational number. But first we need to learn about conjugates. So complex conjugates, that sounds like a big ugly word, but it's actually pretty easy to calculate. If we have a complex number, a plus bi, all we have to do to find the conjugate is to take the negative of the imaginary part. So that's the same as a minus bi. Now here's a little bit of notation. If we want to say conjugate without having to write out the word conjugate, remember mathematicians are very efficient, we can write a plus bi with a line over it, and that tells us to take the conjugate. So the conjugate of a plus bi again is a minus bi. Let's do just a few examples so you can sort of get the idea. The conjugate of 1 minus 2i, we're going to take the opposite of the imaginary part, and that's going to give us a 1 plus 2i. The conjugate of 8i, that's an imaginary number, it's actually a complex number, 0 plus 8i is going to be a negative 8i. The conjugate of 5 plus 72i is going to be a 5 minus 72i. So now we have these conjugates, we can actually use them in our manipulation. So manipulating the denominator, here's our time. We actually get to do some manipulation. If we have the division problem, 2 plus 3i divided by 4 minus 5i, we're going to take a look at the conjugate of the denominator. The conjugate of the denominator, so 4 minus 5i, the conjugate of 4 minus 5i is 4 plus 5i. So there's our conjugate, and we're going to multiply this division problem by a 1. If we multiply it by 1, it is not changing the value. We can't just change the value of this, but we can multiply by a 1. Anything multiplied by 1 is itself. And so we're going to use not just a regular 1, we're going to use kind of a fancy one. So anything over itself is 1. So 5 over 5 is 1. 4 plus 5i over 4 plus 5i, also 1. So when we multiply this division problem by a 1, it's not going to change the value of that division problem. It's just going to make it a little simpler for us, as you'll see. So when we do our multiplication, we're going to use the distributive property. So let's go ahead and look at that. Let's start with this 2. We're going to distribute that 2 to both the 4 and the 5i, and then we'll move on to that 3. So 2 times 4 is going to give us an 8 right here. 2 times 5i is going to give us a 10i. 3i times 4, we're moving on to the 3i. 3i times 4 is giving us a 12i. 3i times 5i is going to give us a 15i squared, which remember, that's the same as negative 1. I squared is the same as negative 1. I wrote that little negative 1 up there to remind us that I squared is going to be the same thing as negative 1. Same thing to the denominator. We're going to go ahead and distribute. So let's take the 4. 4 times 4 is going to give us a 16. 4 times a 5i gives us a 20i. Negative 5i times 4 negative 20i, and negative 5i times 5i is going to give us a negative 25i squared, remembering that I squared is the same as negative 1. Now let's see if we can simplify that a little bit. We're going to add like parts of that complex number. We're going to add our i's together, and we're going to add our real parts together. So we have an 8 right here, and remember this is actually a negative 15 because that I squared is a negative 1. So we have 8 plus a negative 15, and we get a negative 7 right there. We're going to add our imaginary parts. 10i plus 12i is going to give us a 22i. And let's look at the denominator now. So we have 16 right here, and we've got negative 25 times I squared. I squared is negative 1, so we're going to take that as positive 25. Negative 25 times negative 1 is going to give us a positive 25 plus 16 gives us the lovely 41 because the i's right here, our imaginary parts, are now 0 i's, and we have a rational number, which was the whole point of all of this after all. So we have a negative 7 plus 22i over 41, but that is not written like a complex number. Remember, complex numbers have a real part and an imaginary part, and it's kind of blurred in right there. And so we're going to actually take that apart a little bit. So when we have two numbers over the same denominator, we can add them and put them over that denominator. We're actually going to go in reverse. So we're going to take negative 7 over 41, and we're separating that plus 22i over 41. If we were to add these together, they would all go over that same denominator, and we would get back to here. But now we have this in a form of a complex number. All right, let's look at another one. It is kind of a long process to do these, but not so difficult once you get the hang of it. So let's look at another division problem. 3 minus 7i over 2 plus I. And really we're rationalizing the denominator there. That is the same as 3 minus 7i divided by 2 plus I times 1. And we're using a very fancy one right here, not just a regular one. And that fancy one comes from the conjugate of the denominator. So the conjugate of 2 plus I is going to give us 2 minus I. We're going to multiply that by our fancy one, or 2 minus I over 2 minus I. And we're going to do that multiplication by distributing. We're going to start here with the 3. So 3 times 2 is going to give us a 6. 3 times negative I is negative 3i. Negative 7i times 2 is going to give us a negative 14i. Negative 7i times negative I is going to give us a positive 7i squared, remembering that that I squared is negative 1. Same thing with the denominator. We're going to take the 2. 2 times 2 is 4. 2 times negative I is negative 2i. I times 2 is a positive 2i. I times a negative I is a negative I squared, remembering that I squared is that negative 1. Now let's see if we can maybe reduce this and make it look a little nicer. So let's look here. We've got 6 plus 7i squared. I squared is negative 1, so really that's a negative 7. 6 plus a negative 7 is going to give us a negative 1. And if we look at our I terms, our imaginary terms right here, we've got negative 3i minus 14i, which gives us a negative 17i. Now for the denominator part, our manipulation is finally going to give us what we would like. So we've got 4 here, we've got negative I squared. I squared is negative 1, so really that's the same as a positive 1. We've got 1 plus 4, which gives us a 5, and we have our imaginary parts equaling 0. So we've got our rational denominator again. This is not written like a complex number. We need a real part, and we need an imaginary part, so we're going to go ahead and break that apart. Negative 1/5 minus 17 over 5i. If we were to add these together, same denominator 5, negative 1 minus 17, and it would just look 17i, and it would look just like this. So now we have rationalized our denominator.